Alright, so today we are going to be talking about graphing and analyzing data. This is definitely important for you to know, especially in science, because this is how you interpret and show other people your data, and so how you can explain it and kind of make sure the whole world knows what your experiment did and what your findings were and what your conclusions were. So this is very, very important. Alright, so key info for you. Make sure that you review your data before you actually turn it in. Try to look at it, the results of your experiment with a critical eye. Ask yourself these questions. Is it complete or did you forget something? So hopefully you didn't forget to put a title on it. That is the most important thing that you need to do, because if I have a graph, it looks very nice and neat. No title, I don't know what the heck it's talking about. Do you need to collect more data? So is it actually solving your problem? Does it explain what you were doing? Did you graph all of your results? And of course, did you make any mistakes when you were doing it? Also, you need to calculate an average for the different trials of your experiment if needed. So hopefully you did your experiment more than once. And if you were coming up with numbers as your results, make sure that you calculate an average for that. So that means you're going to add up all of your trials and then divide by however many trials that you did. You will be learning more about this in math class with the mean, median, and mode. Mean is your average. So if you know what mean means, hopefully that doesn't get you too confused, the mean is actually the average. Okay, so make sure you do that too. Also, make sure you clearly label all tables and graphs. So again, make sure you have a title. Make sure you have different axes, the y axis going up and down and your x-axis going across. Make sure that you also include the units of measurement. So if you have 1, 2, 3, 4, 5, 6 across the bottom of a table, I don't know if that means, 1, 2, 3, 4, 5, 6 bunnies or 1, 2, 3, 4, 5, 6 lip gloss. Okay, so make sure that you put your units of measurements down at the bottom and the top and all of your graphs all together so we know what you're talking about. Make sure you always place your independent variable on the x-axis, which is that line that goes straight across on any graph that you do, and you place your dependent variable on the y-axis. So it's important for you to know in your experiment which one is the independent variable and the dependent variable, so that way you can put all of your stuff in a table correctly. Also make sure you label your axes, just like the previous slide said. And if you have more than one set of data, use different colors or symbols and include a key. So if you have a line graph, make sure you use different symbols so I know the difference between those two sets of data if you just want to combine it all on one chart. Alright, so this is when you need to fill out your data analysis sheet now. At the top it says Miss West notices that students who study do well on tests. I wonder if she has Miss Dudek, her class as well. She noticed if the amount of time spent studying for a test is related to test scores. She hypothesizes that students who study longer get higher test scores. In order to test her hypothesis, she conducts the following experiment. So look at all of those, what she did, and you need to identify all those questions below. So make sure that you fill out that sheet completely. So you can go ahead and do that now. You can pause this video if you would like. Alright, so I'm going to continue on with good data analysis manners and things like that. So these are some questions that you need to answer to yourself when you are done collecting data. Is there sufficient data to know whether your hypothesis is correct or not? Is your data accurate? Have you summarized your data with an average? Does your chart specify units of measurement for all of the data, or do you just have numbers on there that don't mean anything? And have you verified that all calculations are correct? So you have triple checked your work to know that it's right. So what makes for a good graph? Have you selected the appropriate graph type for the data you are displaying? So for categorical data, you might put it in a bar graph. For quantitative data, using numbers and things like that, you might want to use a line graph. Does your graph have a title? Hopefully you said yes. Have you placed the independent variable on the x-axis and the dependent variable on the y-axis? So make sure you do that. Have you labeled the axes correctly and specified units of measurement? Does your graph have the proper scale? And is your data plotted correctly and clearly? Okay, so don't copy this, but I did want to go over this together, so hopefully you can have this correct when you turn it in tomorrow. In this experiment, what is the independent variable? Okay, so what are we changing in order to get a result? So that is actually the time spent studying over here with these students. So right over here is your independent variable, okay? So of course your dependent variable, or what we're actually measuring, is the score on the test, okay? Alright, and then you need to list 3 control variables, which could be your student IQ, test, learning experiments, study materials, things like that. Alright, for number 4, you needed to actually graph it. And the scale chosen by the student will vary. So it really doesn't have to be by 20s. You could have done it by 10s and things like that, but it would have been all the way up here. For number 5, the results show the independent and dependent variables have what type of relationship? That would be direct, meaning, so you probably didn't know this before, but direct relationship means as the x increases, the y also increases. So as your daily time spent studying increased, so this time increased, we also went up in the test grade. So this would be direct, okay? Inverse would mean as one increases, the other one decreases. So that means your line would go down like that, and no relationship would just be random all over the place. In a complete sentence, write a conclusion Ms. West can draw after analyzing the results of this experiment. You could say that her hypothesis was correct and students who studied longer got higher grades on the science test. In number 7, looking at the experiment design and results, list at least one next step related to the experiment. So, of course, as long as you're reasonable, it's going to be okay. But one example is maybe try the same experiment with a bigger group of students, maybe different subject areas, and then group students with really high IQs, longer time period studying, and see if there's a point of diminishing return, meaning is there other things that are distracting them, or trying to add music and see if that works, if it goes up or down, and kind of figuring out what these students are doing while they're studying to improve their test scores. So you could have said something like that, or you could have some completely different idea that we would love to hear about tomorrow in class. So make sure you have this whole entire sheet filled out, and hopefully it was correct before you even went over it. Alrighty, have a good evening. See you tomorrow.